Hey, welcome back to our series, Flood Geology Failures, where we're going to explore the complexities of Earth's geological record and the challenges it poses to young Earth flood geology theories. Today, we're taking a deep dive into the oceans of the past to uncover the story of cetaceans and sea reptiles, and how their fossil distributions conflicts with the idea of a single global flood event. Sea reptiles, which include the mosasaurs, ichthyosaurs, and plesiosaurs, which I'm going to introduce you to, ruled the oceans during the Mesozoic era, an age dominated by the reptiles. These incredible creatures left behind a rich fossil record, which I'm going to show you as well, that allows us to piece together their biological diversity and the environments they lived in. Yet, according to young Earth flood geology, all fossils were deposited during a single catastrophic flood event. This theory, however, struggles to explain the distinct stratigraphical layers where the sea reptiles are found, distinctly separated from the layers where cetaceans, or modern whales and dolphins, first appear. Cetaceans don't even make their entrance into the fossil record until much later, well after the extinction of the dinosaurs and their marine counterparts at the end of the Mesozoic. This significant time gap and the higher placement of cetacean fossils in the geological column challenge the notion of a simultaneous burial of all life forms during a global deluge. In this episode, we'll introduce you to a few of these awesome sea reptiles, compare the diversity of sea reptiles to cetaceans, which are all mammals. We'll look at the distribution of fossils of each of these groups, both geographically and through time, using the Paleo Database website, and discuss why the distribution of cetacean and sea reptile fossils represents a formidable challenge to flood geology. We've got all that coming up next. In some of my classes, I talk about the incredible diversity of organisms that have ever lived on this earth, and the wild thought that the vast number of species that have ever existed are extinct. And the sea reptiles is a nice example. We're going to look at the numbers of total sea reptiles that have existed, of which none exist today, so all are extinct. And then we're going to look at cetaceans, of which, yes, there are cetaceans. We have dolphins, we have porpoises, we have whales. But the number of different species that are alive today is much less than the total number of extinct species that we know of. So here I've depicted just some of the variety of sea reptiles. So these are not dinosaurs. They're other groups of reptiles, ones that are adapted to living in marine environments. And then we've got the whales. And these are just the 88 living species of identified whales. And of course, there's fewer sea reptiles here, but there have been many more different sea reptiles than there ever have been cetaceans that have lived on Earth. Just to get right to the point, before I then back it up by going to the Paleo Database website, and then we'll actually look at the distribution of fossils across different eras of time to sort of reinforce the point. I can just show you the basic point right here. Here is my really simplified version of the geological column. All right, showing the various geological ages. And then what I've done is I've highlighted where the cetaceans are, right? The cetaceans are only found in the Paleogene and Neogene, not all the way down to the bottom of the Paleogene, which is the boundary between the bottom of the Paleogene would be at the boundary between the Paleogene and Cretaceous, which is most best known as being like the 66 million year mark, where the asteroid impact is. And then below that, you have Cretaceous, the Jurassic, and the Triassic, which is usually called the age of the reptiles or the age of the dinosaurs. And that's the only place where dinosaur fossils are found. It happens to be the only place that sea reptiles are also found. So again, sea reptiles are not dinosaurs themselves. Anatomically, they're different, but they are a group or a type, actually many different types of reptiles that are adapted to the sea that all exist in the same time frame as dinosaurs. But like the dinosaurs, not every dinosaur lived in the Triassic, Jurassic, and Cretaceous, or shall we say, their bones are found in the rocks we identify as the Triassic, Jurassic, and Cretaceous. Some dinosaurs, like T-Rex, are only found in the upper portion of the Cretaceous. This is true for the sea reptiles too. Some of them are only found in one distinct period of time or layer of rock. The cetaceans, that's also true for the cetaceans. There is a distribution of cetaceans in the geological column. But the big point here is that never the two shall ever cross paths. Sea reptiles, all fossils of sea reptiles are found in this earlier period. Then there's a gap of nearly 20 million years. And then you have cetacean fossils above that. Never has any sea reptile or cetacean been found together in any layer of rock. That's a really interesting observation of the geological column. And again, this is one of the things we call the facts of the geological column, right? These are just observations of where the fossils are found that everybody can agree on. Now we have to have an interpretation of that. How can we explain this distribution? Flood geology comes along and says that this entire geological column, well, at least up through the Cretaceous for most young Earth creationists. Some young Earth creationists push it way to the near top. But most young Earth creationists, at least all the way up to the Cretaceous, was all laid down at the same time in a global flood. So had there been many different types of cetaceans living in the pre-flood world, where are their fossils? Why aren't they found with sea reptiles? You know what? I can make some of these points and show you better pictures than simply this graphic. So let's show you just a few examples to get you acquainted with the sea reptiles. Ichthyosaurs, right? 200 named fossil species of ichthyosaurs from thousands of different specimens. They've been divided taxonomically into 25 different families. So a family level will be saying that there's significant differences between these, one set of ichthyosaurs versus another. 25 families also represents, for young Earth creationists, generally the category of a kind. So that would suggest that there could have been 25 different kinds of ichthyosaurs in their minds that God created. So 25 separate creations of 25 kinds of ichthyosaurs. And all of them are only found in this one segment of the geological column. Wide variety of shapes and sizes, diverse food sources and so forth, right? That's the ichthyosaurs. Then we've got the awesome plesiosaurs, more than 250 identified species from the fossil record. Now the plesiosaurs, some of them were very, very large. So here's some relatively large skeletons of these long-necked things. So 250 species of those. We got 200, 250, and then we've got another 100 species of mosasaurs. Now, the mosasaurs are only found in the Cretaceous. Those prior to are found distributed across those three different eras, but three different periods. But here we have the mosasaurs. They're only found in the Cretaceous. So we'll look at that in the paleo database. And again, a wide range of various sizes. And we think that, scientists think that each of these three groups is potentially a monophyletic group, meaning that they have a common origin. And then the evolution of all the different diversity from a common ancestor. But all three don't necessarily share a common ancestor as an aquatic marine organism. This might represent three separate origins of marine adaptation of reptiles that formerly lived on land, adapting to the sea, just as cetaceans are considered to be an adapted land mammal, right, to the ocean or to an aquatic lifestyle. Right, so brief comparison between the two. Sea reptiles, more than 500 known species, but all extinct. 200, and they've spanned the range in terms of the geological column between 240 and 65 million years. So those 500 species are spread across a long period of time. There's no single time slice in which all of those are present. They came in lots of shapes and sizes, specialized in many diets, and they're found worldwide in marine rocks. Then you've got the cetaceans. There's 88 identified living cetaceans. We've got over 150 fossil species of cetaceans. And they're spread across about 45 million years of history, from 45 million years ago all the way up to the present. Of course, they come in many shapes and sizes, specialize in many diets, right? You've got filter feeders, you've got clam eaters, you've got fish eaters, right? You got more vegetation eaters. I mean, so you got a variety of different diets, and they also are found worldwide in marine habitats and even in a few freshwater habitats. Okay, so what we're going to do, the only thing we have left to do here is we're going to go to Paleo Database, because I want to, I'm telling you this is where they're found, but let's go look at tens of thousands of fossil records and look at the distribution of these, because we can tease this out even a little more precisely. So I'm going to talk about the age of the reptiles, but let's go through different portions of the age of the reptiles and look how the distribution of fossils changes over that time for these various groups. Okay, here we are. We are at Paleobiology Database Navigator. I'll put the link to this below this video. Really fun place to explore if you've never been there before. And what we're seeing at first is we're just seeing the distribution of tons of different fossils. We see we have 233,000 collections, which include 1.6 million fossils, right? So these are all fossils that have been curated in the sense of we have good identifications of these. Now, this wouldn't be like all the fossils known in the world, right? This is actually still a small selection of that, but it's a large enough selection that you get a good sense for the patterns that are present. Okay, let's start out with the mosasaurs. Mosasaur, and we went to look at the Mosasauridae, which is the family. So when I entered that, actually I got to move myself here. Let me move myself so you can see my filters here, so you can see what we're looking at here. Got the Mosasauridae. So that's the distribution of the fossils that have been found that belong to this family. They're in this particular database. All right, like I said, there's other fossils that aren't in this database yet, but this is a large database, so it's going to give us a good sense. All right, so we have Central North America over here in Europe, and we have a few scattered things in the Middle East and a little bit down the coast of South America and so forth. All right, a few in Australia. So this is a worldwide distribution. Oh, even all the way down here in the tip of Antarctica. So mosasaurs found, I think we'd say from worldwide at some point. But you notice that these are all greenish and light greenish dots. So I'm going to go to the Mesozoic, because what we're looking at right now, in case you weren't aware, we're looking at the entire Phanerozoic. That is the time from the Cambrian all the way up to the present, so representing 500 million years. So any fossil found within any of that time span is being shown here. Well, we want to zoom in to the Mesozoic. Right, so I'm going to click on the Mesozoic, and I still see the exact same dots, meaning all the mosasaur fossils are all found in rocks dated to those periods. But they're all green. And you notice we have the Triassic in purple, we've got the Jurassic down here in blue, and we have the Cretaceous in green. So I can click on the Cretaceous, and there they all are. Actually, if I go to the Jurassic, they disappear. And if I go to the Triassic, they're not there either. So nothing in the Jurassic, all in the Cretaceous. So let me double click on the Cretaceous. We'll expand out on the Cretaceous. And then let's go into the subdivisions in that. So you have early Cretaceous. Whoa, look, I clicked on the early Cretaceous, which runs 145 million to 100 million years. And then the late Cretaceous is 100 million years to 66 million years. Well, in the early Cretaceous, we've got just a couple accessions, a couple known places where we have mosasaur fossils, which presumably means if I click on late Cretaceous, boom, there they are. A lot of diversity. Now, we're not going to zoom in all the way into different genera, right? There's 100 different species. There's different genera and groups within the mosasaurs. But I'm pretty sure you're going to see that you have very limited diversity here in the early Cretaceous. And then you have much greater morphological taxonomic diversity here in the late Cretaceous. So what it appears is there was nothing before this, right? and then you have a few examples. Oh, we can zoom in even more, right? We're in the early Cretaceous. Let's double click on that. And now we can click on the subdivisions within that, the early Cretaceous, and we got, I see no dots. And then I click here, then I'm up to 129 million years, I see nothing. And I'm up the Birimian, I got no dots, right? Yeah, no, I don't see anything. And then we get to the Aptian, and I'm up to 113 million years ago, the early Cretaceous. And oh, we've got a dot finally in the early Cretaceous. So when we go to the late Cretaceous, we can zoom in a little bit more and we can see that, you know, if I'm at 100 million years, we just have a few dots, you know, a few representative samples that are in that period. And then we get more, and then we have some more, and then we've got some more, and then we've got a whole bunch more. And then at the end of the Cretaceous, actually there's more in Europe now and fewer in the US. So maybe the total diversity of mosasaurs is starting to, you know, lag a little bit here at the end of the Cretaceous. And of course, at the very end of the Cretaceous, then that's the end of the mosasaurs because there's nothing after that. All right, we got to go back out to, let's go out to the Mesozoic, Mesozoic, and then we can go to the Paleogene, and yes, we have no dots. All right, we got no samples, no citation, no collections of them. All right, so that's the mosasaurs. Keep that in your memory bank. Mosasaurs, basically all the diversity, all of them found in the Cretaceous. And the vast majority of the diversity is found in the late Cretaceous. So let's get rid of the mosasaurs and let's go in the Paleogene. All right, and let's go to plesiosaurs. Plesiosauria. And we're going to do the order, right? The largest grouping of them. And so let's go to the Paleozoic, right? So that's 252 million years ago and older, and I see no collections. And then we go to the Mesozoic, and boom, lots of collections all over the world of plesiosaurs. And we go to the Cenozoic after 66 million years, and they all disappear. So we can do the same thing, but now we can go to back to the Mesozoic, and we can look at the Triassic, and we see that there's a few here in Europe, right? I see some dots in Europe. And then we go to the Jurassic, and we see, oh yeah, they're spreading now over a lot more area in the Jurassic. And then we've got the Cretaceous, and in the Cretaceous, we have a larger distribution, a bunch more diversity of plesiosaurs. Although I can go to the early Cretaceous and then the late Cretaceous. It looks like in the late Cretaceous, they're doing pretty good. Got a lot of different plesiosaurs in the late Cretaceous. And again, I flip over to the Paleogene, and immediately they all disappear. So that's the plesiosaurs. Let's do ichthyosaurs. Ichthyosauramorpha. Yeah, we're going to do the family here. Let's get rid of the Paleocene filter. Let's go to Phanerozoic, 500 million years of history. And here are all the different collections, 106 total occurrences of ichthyosaurs. Not nearly as common as plesiosaurs. I don't know if you noticed, but there was thousands of collections of those. And so we have some, you know, actually we have South America, North America, nothing found in Africa, here in Europe, a little bit in Asia. So much less distribution of these. But if I go to the Triassic, just a couple dots. Jurassic, we have more diversity, and we get to the Cretaceous, and there's a few in the, we go to the Cretaceous, and there's not much in the Cretaceous. So it seems that the heyday of the ichthyosaurs was the Jurassic period. So we've got two types of sea reptiles in the Triassic, and then in the Jurassic, we seem to have the most diversity of those two. And it's not until the Cretaceous then we have the mosasaurs, but then we see a contraction of the other sea reptiles. So it's as if, hey, we got more competition here, and they're, you know, the mosasaurs seem to be doing really well and maybe out-competing some of those other sea reptiles. But point being, the age of the reptiles is the only place where we see fossils of these. So now let's look at cetaceans. Oh, you know what? Let's do all three of those together. So now we've got them all together, all three groups of sea reptiles. Phanerozoic. Again, nothing in the Paleozoic. They're all in the Mesozoic, nothing in the Cenozoic. If we go to Triassic, not a lot of diversity in the Triassic. Between the three groups, the Jurassic, and then the Cretaceous. But in the Cretaceous, a lot of those are mosasaur samples and plesiosaur samples. Great. Let's get rid of ichthyosaurs, plesiosaurs, mosasaurs, and the Cretaceous, going back to everything. But now we're going to do Cetaceae. All right, so what we got here is, here's all the collections of cetaceans, including a lot of dots out here in the ocean, which would be on islands. And a lot of these are going to be like subfossils, so things that are like very recent collections that are not fully fossilized. So subfossils. And I want you to know something about the distribution. All right, so if you're watching before with the sea reptiles, we had huge numbers of them in inland North America. We had a lot of them in northern Africa. We did have a lot of them in Europe as well. There was some a little more internal in Australia, and there was the same thing. They're sort of down the coast of South America in terms of the general distribution of the sea reptiles. But here the cetaceans are very much hugging the coast, right? And part of this is because cetaceans are much more recent, and over the last 40 million years, the overall distribution of the continents is very similar, and there haven't been any inland oceans during that time. Whereas during the Jurassic and so forth, there was large inland oceans in some of these continents, and it was in those shallow seas that many of these animals thrived. And it's also, well, that's where things could get preserved that we can see today, because we're seeing fossils that are above sea level, right? And so all the different cetaceans and sea reptiles that lived in the open ocean and fell to the bottom of the ocean, their fossils are going to be rather hard to find, right? So we're missing a large portion of that fossil record. But all this coastline are areas that either when sea levels were higher or the land has been lifted up through some kind of plate tectonics or so forth, has raised the lower, what was a shallow seabed above sea level, and that's why we can see those fossils today. And that's similar to Europe. I mean, Europe has had a lot of shallow oceans at various times in the past. All right, so the cetaceans. Well, what do we need to know about the cetaceans? Well, this is all the cetaceans across, the entire geological column. Let's go back to the Paleozoic. Okay, we got no cetaceans whatsoever of any type. We go to the Mesozoic. We've got no cetaceans. Right? That's the whole point of this video. There's no cetaceans here. And then we go to the Cenozoic, and boom, they all appear. But we gotta scroll into the Cenozoic a little bit closer. Let's go to the Paleocene. Nothing. Right? So there's your gap. You've got sea reptiles. Then you got nothing in the oceans of that time. And then we go to the Eocene, and now we start seeing a bunch of different cetacean fossils. But I can go to the early Eocene, Pakistan. Here we got these ones over there in Pakistan, India. Do you know what fossils are found in Pakistan? Well, there's that thing like Pakasitas. It's considered one of the earliest things that has anatomical features that are similar, related to cetaceans. So are thought to be some of the earliest cetaceans. Those are the oldest fossils found in that particular area. So let's see, that's getting us up to, they don't have the dates on here. And I don't have my dates memorized for these different sub-periods. And then we see more of them, and then we've got more of in the Prebonian. And then we get up to the Oligocene, right? And then we've got some more there, and then we've got more here. So I get the whole Oligocene. Got them kind of distributed around the world, but down here in New Zealand, Australia. And then we get to the Miocene, and wow, now we've got a lot of other cetaceans. And these cetaceans are going to be a lot more familiar to you, more similar to cetaceans that are alive today. And then we could go through this. If we go to the early Miocene, not so much. And then as we move up the Miocene, we're getting more and more diversity of cetaceans. All right, the Pliocene, and then we get to the, let's look at the Quaternary. So this is, these things are all hugging the coast. Why? Because the Quaternary only covers the last couple million years, and there hasn't been a lot of uplift and not a lot of inland seas during that time. There's been some, oceans going up and down, and so there's only limited places where whales can get preserved in a situation where we're going to find them on land, and they're always in and they're always going to be found in very low elevation places like Florida, okay, which has been covered with water in the past. So there's a chance for whales to get preserved there for us to see today. All right, I just wanted to, I've done it before, but it's always fun to share this particular place, because you're looking at thousands and thousands and thousands of accessions by many, many, many different researchers across the world that are entering their information into these databases. So they're being collected from various publications and so forth and entered into this database. And so even though it doesn't have every single sample in it, gives you a nice feeling for what is the distribution of fossils throughout the geological column. So young Earth creationists are faced with a situation where if they think that the flood layers end right here, well, let's go back. If they think that they end right here at the end of the Cretaceous, right, which there is a large number of young Earth creationists that would promote this idea that the post-flood flood boundary, so the flood ends, and then the material laid above that is sort of in this post-flood world, then every single cetacean fossil, of which there are a lot. What we have here, we've got, well, this is 1,400 different occurrences of cetaceans. And like I said before, this isn't the entire fossil record, but thousands of fossils of cetaceans covering the around 200 or so different species. And so we've got a lot of samples. And every single one of them, though, would have to be explained as having been fossilized after the flood by post-flood events, like during some sort of ice age or something like that. And you have to explain why no cetacean seems to have been killed in the flood. Like, why didn't any cetaceans get preserved? Those cetaceans live in the ocean. They eat similar types of foods that the different sea reptiles would have eaten. So they must have lived in similar habitats if they both, in fact, lived at the same moment in time, right? They're both present in that pre-flood world, in the pre-flood ocean. And so you have this chaotic global flood that captures and preserves more than 500 different species of sea reptiles. And somehow every cetacean escapes. Every single cetacean managed to wiggle their way out of not being preserved, not showing up in the fossil record. And then there's a gap after the flood where there aren't any cetaceans. And then only later they begin to show up in the fossil record. That's a very curious distribution. Now, old Earth creationists, evolutionary creationists, we didn't have any really difficulty explaining this. The pattern was that you had very low diversity, very few types of ichthyosaurs or plesiosaurs or mosasaurs early on in one of these eras, right? Like the Triassic. And then you see more and more and more different and more diverse. I'm not showing you the pictures of the actual organisms, but we could go through and look at dozens of them and show that they become more divergent from one another as you go through up the fossil record. And then they begin to disappear, like many of them go extinct. There's sort of a final extinction of the last ones. So the sea reptiles seem to appear in the record, and then they diversify, and then they go extinct. All the while, there doesn't seem to be any cetaceans. And then you have the asteroid impact, and you have the great extinction of 66 million years ago. Then you have a period of 15, 20 million years, and then you have the very first inkling of organisms that are cetacean-like, like Pakicetus, but isn't completely adapted to living in a marine environment. But then soon after that, you had the very first marine adapted cetaceans, but only a few. And then you have more and more and more and more and more diversity. And today you have like 88 of them living today at this period of time. So that follows a pattern of sea reptiles ruled the world to the exclusion of any kind of mammal being able to hone in on its territory. But once the sea reptiles are gone and they go extinct, there's a tremendous amount of resource in the ocean. All the different types of foods that sea reptiles ate no longer being eaten by sea reptiles. And so mammals were able to take advantage of that particular resource and adapted similar traits and characteristics. I don't even know how similar. I didn't show you cetaceans, but you've all seen dolphins and porpoises and whales. And when I showed you some of those pictures of ichthyosaurs, plesiosaurs, and mosasaurs, a lot of similar features, even though they're reptiles versus mammals, right? So they have a large number of physiological differences. However, their bodies have been sculpted into similar shapes, right? And they have similar tooth type structures depending on the types of foods that they eat. So anyway, that is this week's flood geology failure or challenge to young Earth creationists to model how they explain this weird distribution, disjunct distribution of sea reptiles versus cetaceans. Thanks for listening. We'll talk to you later. Bye-bye.